Hello, my dear energetic students. How are you? All set to crack the NSEP exam and other exams, JEE, NEET. So, whatever your targets are, whatever your goals are, you're going to achieve them with your determination and hard work. Now, I'm back with this series of Noodle Chopsticks, and we have spoken earlier as well that this is not just a fancy name given to a series just to attract students. It's more about, so let's say there is a task that you have to undertake. Now, there are two options you have. Either you go this noodle method or you go chopstick method. Obviously, this is more cluttered. It takes you to the same place, but in a fancy way. But this one is a straight line method, and that's why I call this series a noodle chopstick series, where you have an option to go noodle route or a chopstick route. I prefer chopstick route because the noodle route is definitely very, very confusing. It is going to be lengthy, it is going to be error prone, and it is going to be very difficult to grasp. So if that is the case, why do some teachers prefer that? Maybe because they learned it that way and they do not know that there is a simpler route out there. Or maybe they want to portray the concept as a rocket science to you so that you are amazed by it. So whatever the case, I don't know. Let's go the chopstick route. So today I'm going to start with a new topic here, but before that, my name is Bhavdeep Sethi. I've done masters from IIT Bombay, and I have a passion to convert physics haters into physics lovers. And I always say, do not ever memorize physics. Physics is all over you in the nature. Look around you, learn physics from the nature. Nature is the best textbook out there. So today we'll talk about the drift velocity. Now, this drift velocity is from the electric current chapter. And I really get very sad when I see students memorizing the derivation of drift velocity. They're memorizing lines and lines and lines and then just spilling it in the exam, but they don't understand what that actually is. So today I'm going to show you how easy it is to understand what is drift velocity. Now, as with every episode of this series, I'm going to cover the prerequisites also. So what is electric field? So electric field is basically the force per unit of charge. So let's say there is an electric field here. So electric field is, let's say, 7 newtons per coulomb. The units itself reveal everything about it. It's newtons per coulomb. As in, if there was a 1 coulomb of charge sitting here, it is going to experience a force of 7 newtons. Because see, 7 newtons per coulomb. Every coulomb experiences 7 newtons. So let's say if there was 2 coulombs here, because it's 7 newtons for every coulomb, 2 coulombs would experience 14 newtons of force. So how much force is experienced, that is equal to the amount of charge times the electric field. So in this case, you can see force experienced, this charge, which is 2 coulombs, times the field, which is 7 newtons per coulomb. And this is where coulombs and coulombs will cross out, and you get the answer in newtons because forces are in newtons. So again, one more time, electric field. What is field? Field is the amount of force experienced by 1 coulomb of charge. Now, Newton's second law. So that's another prerequisite. I know you know that, but let's still cover that. So Newton's second law is the force experienced by a body is equal to the rate of change of momentum. But from that, assuming the mass is constant, we can derive this very useful information, very useful equation, which is F equals ma, where force is a vector, acceleration is a vector. So let's say there is a box here, and you apply a force of 20 newtons to the box, and box is 5 kilograms. So you will say 20 is equal to 5 times a, as in this box starts accelerating with force divided by mass. So acceleration is equal to force divided by mass. Force is 20, mass is 5, so 4 meters per second square. So that is the Newton coming from Newton's second law. Okay. Another thing is Utsav. Utsav is the three equations of motion. When things are accelerating, you use one of these equations. V equals U plus AT. And let's stick to this. Other two we don't need for this video. So V is equal to U plus AT, as in if U is the initial velocity and A is the acceleration, T is the time. So the final velocity is this, which is very intuitive. If something is moving with U and its velocity is changing some amount every second, after T seconds, it will change this much. It already had this much. It is changing by this much. The final velocity will be this. So let's see. Let's start. What happens inside of a conducting rod when there is no battery? You go to the market, you purchase a rod. Let's say this is a copper rod. What is happening inside this rod? So let's say this is a rod. And when you have some supernatural powers, then you can see those electrons. Conducting rod as in a metal. So if it is a metal, it's a conducting rod because it has free electrons. If they are free, they are going to move around randomly. So there is an electron here in some random direction with some velocity. Let's call this u1. It is going to be moving. I don't know what direction, what velocity. I'm just saying I chose random direction there. There is another electron which is moving here like this with u2. And remember, velocity is a vector quantity, u3, u4, right? So this is u4, u5, u6. So you can see the electrons are moving in all random directions. We don't know. I mean, they're just moving in all possible directions. Now, the theory of randomization tells me as the number of electrons are huge, everything will add up to zero. Because say, if there were 10 electrons, chances are more were moving left or more were moving right or up or down. But when there are trillions and trillions and trillions of them and they are moving in random directions, obviously all the velocities cancel out. Remember that it's a vector quantity. So every component of velocity here would have a counterpart there. Every velocity component here will have equal and opposite counterpart there. So can I say that the velocity u1 plus u2 plus dot all these up to trillionth and trillionth of that, all these added up add to zero. It's a vector quantity. Remember, directions matter. So inside of a conducting rod, when there is no battery applied, what would now happen is with thermal agitation, with thermal energy, they are going to move in random directions and all the velocities add up to zero. So they are moving, but the net velocity is zero. Now, what is mean relaxation time? So let's talk about one electron now. Now, we were showing only electrons there, but that's not the case. So inside the metal, when the electron becomes free, what is left behind is a positive ion, and these are not free. So they are just sitting over there. So these electrons, they are not, so the electrons are free. These ions are not free. So let's say an electron starts moving in this direction. It is going to collide. When it collides, it's a collision, it's an elastic collision, and it will take some route, and then it collides, it takes that route, it takes this route. So they keep colliding. So maybe 1 second later it collides, 1.1 second later it collides, 3.29 seconds later it collides. So different times. So can I say it collides after 1 second? This is, let's call this T1 time. This is T2, T3. All these times are different times, but we can have an average of those. So that average is called the mean relaxation time, denoted by letter tau. So this is mean relaxation time is the mean, the average time for which we can assume the electron was freely moving. Obviously, we're not taking the mean of this electron, we are taking the mean of all the electrons out there. So mean relaxation time, one more time, what is it? Mean relaxation time is the average of the times when the electron was moving freely without colliding prior to collision. Okay, now let's apply battery. So what happens with battery? So with battery, things are going to be different. So let's say there is an electron here. So let's take a conductor here and then let's apply some battery here. So let's say I apply a battery here. So battery has a positive terminal here and a negative terminal here. That means this side becomes positive and this side becomes negative. Now there is an electric field. There is an electric field. You have studied electrostatics. There is an electric field. And that electric field will apply a force on the electron. Remember, fields apply force on charges. Electrons are charges. So how much force each electron will experience? Electron will experience a force of the charge multiplied by the field. So charge on electron is denoted by letter E. E denotes 1.67 times 10 to the power negative 19 coulombs of charge. That is charge of electron. So electron will experience a force equal to the charge of the electron times the electric field. Here, force is a vector, electric field is a vector. So this is the force experienced by an electron. Where there is a force, there is an acceleration. So now comes the famous equation F equals m. You see how these things are glued up together. We are studying current, electricity, and in here we are using the Newton's second law equation. So if there is a force, there is an acceleration, which is again a vector, and that acceleration should be force divided by mass. So this is the acceleration. Wow, that's interesting now. So what it looks like that each of the electrons, see, each of the electron has equal charge, each of the electron has equal mass. All the electrons, irrespective of whether they're going left, right, up, down, they all experience one single acceleration in one direction. So what will happen now? What will happen now is this electron, which was moving with velocity u1, and now see the beauty of this. We are in the current electricity chapter. We use the second law of motion, and now we are using Utsav over here. So there is an electron with velocity u1 experiencing this much of acceleration. So what will now happen? It will change its velocity. v1 is equal to u1 plus at. V equals u plus at. Now a is this e by m times t1. So t1 as in, let's say T1 is tau 1. What is tau 1? Tau 1 is the mean relaxation time of that electron. Right, this electron will accelerate unless it collides. And then it again accelerates unless it collides again. So this is the time for which it was freely moving. Now, similarly, there's another electron. Let's say this electron had a velocity u2 here. So then I can say, let me move this part here. Maybe this doesn't belong here. Okay, this is good. Okay. Uh-oh. Okay, anyways. Okay, sure. Now, the velocity of the second one is very similar. It is u2 plus e. So remember, this acceleration is same for all the electrons. Tau 2. Now, if I add all the velocities and I want to find the average velocities or something like that, so what is all this velocity coming out to be? That velocity is basically the average velocity with which the electrons are drifting now. So what is that average velocity coming to be? If I add all this, I get v1 plus v2 plus v3. That is the velocity. And then I will definitely divide it by the number of electrons to get the average velocity. But look, what are you getting on the right hand side? Right hand side, you're getting u1 plus u2 plus u3 plus u4. But wait. That was zero. The initial velocities being vectors, they added to zero. So this part, which I'm coloring yellow, this part becomes a big zero. And what do you get in addition to that? What you get in addition to that is E by M, tau 1, tau 2, tau 3, tau 4. So that is the sum of all the free relaxation times. Now I took the sum of all the velocities and divided by the number of electrons. That gives me the average of this. And I do the same thing here, add all these because that comes out in the bracket here. So those divided by the number of electron gives me the average relaxation time. So this, my dear friends, is the drift velocity. Very easy to understand. So all the electrons are drifting with this velocity on an average. Right. So again, one more time, what happened here is we added all these equations and we divided by the number of electrons to get an average, because now I'm getting the velocity 1 plus velocity 2 plus velocity 3. All these velocities divided by trillion. That gives me the average of this. On the right hand side, this part was anyway zero. This was a constant I took out, and in the bracket I have tau 1 plus tau 2 plus tau 3. All these taus added together divided by the number of electrons gives me the mean relaxation time out there. So this is the drift velocity formula, so easy to understand. But now comes the best part, effect of temperature. Intuitively, it looks like when temperature increases, the drift velocities should increase, because it looks like, oh, if the temperature is increasing, those electrons have more energy and they should drift more. But that's not the case. So let's understand why. So what do we have here? We have here V1 is equal to U1 plus EE by M, and I'm not making that vector notation there. It's intuitive here. So tau 1 plus V2 plus U2, V2 is equal to, I'm really sorry there. When I'm thinking and writing, things do go wrong sometimes. So this is U2 plus EE by M times tau and so forth. So what happens when you increase the temperature? If you increase the temperature, electrons have more energy. If they have more energy, these U1, U2 will increase. That initial velocity of electron 1 will increase, 2 will increase. But wait, even if they increase, they are all increasing in the same proportion and they still add up to zero because they're moving faster, but still in the random direction. So that doesn't matter. This still adds up to zero. But what happens next? What happens next is I get the same formula where the drift velocity is EE by M times the mean relaxation time. But if they were moving faster, they were colliding faster. Think about it. I mean, think about it. If this is a positive ion, there's a positive ion here. If the electron collides with this and then moves there, if it's moving faster, there is less time before it collides again. So more temperature means more energy, but that also means less relaxation time. It will collide more frequently. And that basically means the drift velocity will slow down. And that goes hand in hand with the concept that you memorize, not you, but some students memorize. With the increase of temperature, the resistance increase or resistivity increases. Why? Because with the increase of temperature, that drifting reduces. See, my friends, increasing temperature increased U1, U2, but that increase has no role to play in the drift velocity because that averages out to zero anyways. So drift velocity is basically this expression. The charge of electron does not change with temperature. The electric field is dependent on the battery, does not change. Mass does not change, but this number reduces it. It collides faster. It has less relaxation time. So if this is less drift velocity. Less drift velocity means less current flowing. Less current flowing means there is more resistance. This explains at the microscopic level that why with the increase of temperature, the resistivity increases. And wasn't that very easy with that chopstick method? I'm going to bring more videos. Do like, share, and subscribe. Let your friends know about it. And by the way, I will keep coming on YouTube with these videos. But we have also launched NSEP Module 3. You might be interested in that. So what is NSEP Module 3? We have the NSEP program as 5 modules. We started in January with Mechanics 1 and then Mechanics 2 in March, April. Now in May, we are starting Mechanics 3. The classes are starting. I'll show it on the next slide. But even if you've not joined these two, that's okay. Because if you purchase this, I'm going to give you the free videos of this. And by the way, this is a Hindi medium batch. So you have to remember this is a English batch. I know I just want to make that clear. This is Hindi plus English. I am going to speak in mixed language there. So in the module 3, we cover mechanical properties of solids, which is modulus of elasticity. Then fluid mechanics, like the flow of fluids, Bernoulli's equation, Stokes' law, the surface tension, those things, thermal energies, thermodynamics, refrigeration, air conditioning, scooter, motorcycle engines, then simple harmonic motion waves. All these are 11th topics. And then we go to module 4 and 5 for 12 topics and 25 hours of live, no, 25 sessions of live classes. So every class is 1.5 hours. And the classes are Monday, Wednesday, Friday, 6 to 7:30. 16th May is the start time. Price is only 2,500 rupees. But if you apply this coupon BS Pro 1, you get 10% discount there. But then if you buy module 3, 4, 5 together now, so 2,500 times 3 7,500, you get 1,000 rupees discount. But usually when you go to shopping website, they say, okay, one discount at a time. You can use both of them. You get this 1,000 discount, but then you also can apply this coupon BS Pro 1. You get further 10% discount. So what is the total price? Total price is this minus 650, which is 5,850 rupees. And that gives you all 3 modules plus the 2 modules as recorded earlier. You also get doubt clearing. You get Sunday test. Sunday you will have a test. You get assignments on Telegram, you got doubt clearing on Telegram. So everything is covered in that price. And free recording for previous modules. Where are we? Where are we? Where are, yes. So if you need any help, you can call our team member Ayush. He's a very helping person. You can note down this number. He is going to help you. Anytime you need help with enrollment, he's going to help you. And I always show Dhruv, Aditi, Avnish, and these are the medalists we had last year. And if they can do it, you will do that. So these are the students who got gold medal. He got a gold medal for India along with other team members. So physics gold for India and chemistry silver for India. So if they can do it, you can do it. All you need is high energy and high joy. So I'll keep seeing you on YouTube. And if you want to join those courses, you can call that number or click on the link below here. I want to clarify this course I was talking about is in Hindi plus English. So I'll be speaking a mix of language in the class. So see you, beta. Keep up the high Josh and high energy. I'll see you soon.